Welcome to Engineering Archives. Let's look at practice problem number 6 for the chapter Cartesian vectors. So the problem says, determine the magnitude and coordinate direction angles of the resultant force acting on the eye bolt. So we have two forces and we have to first express them as Cartesian vectors and then we have to add them. Then we can use the resultant force formula to find their resultant magnitude, and after that we can use the formula to find their coordinate angles. Okay, so let's get started with the z and y direction. Okay, so the y component of F2 is going to be 450 cos of 45, while the z component of 2 is going to be 450 sin of 45, and these are going to be equal to 318.2, both of them. Okay, so let's move on to F1. Its component in the x direction is going to be equal to, but before we can do this, we need this angle right here. We need this angle, and we can find this angle using this triangle that they have given to us. Using the tan identity, we get theta equals to 36.87. So for the x component of F1, we can do 600 cos of 36.87 cos of 30 degrees, and we get 415.7. Moving on to the y component, we get negative 600 cos of 36.87 of 3 degrees, and we get negative 240. Lastly, for the z component, we can simply do 600 sine of 36.87, and we get 360 newtons. Now that we have all our components for all forces and all directions, we can write both of them in their Cartesian forms. So F2 is going to be 308. So F2 is going to be 318.2 newtons. 318.2 J plus 318.2. So F1 is going to be, this Cartesian form is going to be 415.7 I minus 240 J plus 360 K. Adding their respective I, J, and K components, we get the resultant force 415.7 I plus 78.2 J plus 678.2 K. Now that we have the Cartesian form of the resultant force, we can use the resultant force formula to find its magnitude, which is the sum of its components, sum of the square of its components in all directions. The value that we get for the magnitude of resultant force is 1/2 to 800 newtons. Now that we have our resultant force, magnitude for resultant force, we can move on to find the coordinate angles. So we're going to use the coordinate angle formula, that is cos of theta x is equal to the component in the x direction, which is 415.7, divided by the magnitude of the resultant force, which is 800 newtons. And for theta x, we get 58.7 degrees. Moving on to theta y, we get 78.2 in the right direction. The magnitude of the resultant force. The value for theta y is equal to 84.5 degrees. Lastly, theta z, we get 32 degrees. So this was this easy but lengthy procedure. So thank you very much. See you in the next video.